Welcome to this new lesson. In this new lesson, we will implement the semantic search function. This function will get a search term and a list or target list of other terms. It will then get the embedding for all of them. It will measure the cosine similarity or the similarity between the search term and each of the list items. It will return the top k, which is another parameter to the search function. It will return the top k closest list items in the list. So you pass a search term, list of or target list of text, and k, the number to return. It will measure the similarity between the search term and every item in the target list, and it will return the closest top k. Okay, let's start with that. Let's go back to the controller. Now here we will define a new function. Let's add it here after the append to cache. So first we will declare this function. It's called semantic search. It will take a search term, target list, and k. It will obtain all the embeddings for the search term and the target list. It will measure the similarity between the search term and each of the target list, and it will return the top k closest target list items to the search term. Closest means the cosine similarity is close to 1. So first we will get the embedding for the search term. We will use generate embedding with cache. We will always use the cache so we don't make a lot of requests. Then we will get back the embedding for the search term. Then we will create a list that contains all the similarities between the search term and the target list. We will then loop over all the items in the target list. We get each item text. Then for each of these items, we will get the embedding, and again using the cache. That will give us the target embedding. So now we have the embedding of the search term and the embedding of this element. We will then measure the similarity between them. We will use the cosine similarity to measure the similarity between the search term and the target embedding we are working with now. Now we will push an object about this item to the similarities list which we have defined. This object will contain the index in the target list, the target text itself, and the similarity which we just measured. We can then add the embedding vector as well for the target, but maybe not a very good idea because it is a large vector. So for now, I will keep it commented out. Now we will loop over all the items. We will get the embedding for each item. We will measure the similarity with the search term, and we will add an object in the similarities list. Now after the loop, we will actually first sort the similarities in descending order. We have the similarities list here. This sort function, it will call the anonymous function that we provide in order to perform the sorting. Of course, it will pass the first number and the second number, or the first object, similarity object, and the second one, and we will sort them based on the similarity. This will make the ones that are very close to the search term at the top because they are closer to 1, while the others which are less related to the search term will be below because their similarity will be closer to 0. With this, we are almost done. All what we need now is to return the similarities, the top k similarities. Remember, we have here the k passed to this function. We need to return the top k similarities. So that's what we are doing here. So that's our semantic search function complete. It takes search term and target list and the number of similar items to return. We get get the embedding of the search term, we get the embedding of each item in the target list, we measure the similarity, we add it to a list all similarities, then we sort by similarities in descending order, and we return the top k. Finally, let's go and export this function. In fact, we don't need the other ones, so now we just export this semantic search function. Let's now go to the playground so we can test it. I will first modify the import here. So we now just import the semantic search. I will then comment out all of this. I will now define a target list, and in this list I will add some entries. So these are the entries. I have 10 entries, I think. 5 of them have to do with the rain, and 5 of them have to do with shopping in the groceries. I will then make a call to our semantic search function. We pass to it the search term. It is raining, it's really raining outside, and the target list and the k, which is 5, to get the top 5. Now this is asynchronous, so let me attach then. Then I pass an anonymous function that will log out the result. I will also attach a catch block in case there is an error. Of course, the response here from the semantic is the similarities array that we have defined here. Let's now go ahead and test. So I will launch this. It will take time the first time because it will go to the API in order to obtain embeddings of all the 11 statements that we have defined here. Now we can see this is the similarity object. It is very similar to index 1, which is the second one, index 3, index 0, index 4, and index 2, which are the top 5 indices. In fact, let's make it top 10. Okay, so let me run this. It will be much faster now because it's reading from the cache. You can see that the first 5, which are about rain, are much closer, 0.9 something, while the other ones you can see that they are further because they are about groceries. Okay, let me make another example. So this example, now we are talking about the grocery, and let's get the top 10, all of them. So let's try it. You can see that the things that are talking about grocery and shopping are at the top, while the things that are talking about the rain are at the bottom. These are 0.7, 0.7, and these are 0.9, and this is 1 because we have an exact match. So this is about our semantic search function. Next, we will convert this to a REST API, and finally we will write the web page.